In this video, we're going to go through an introduction to lists. We've already looked at one sequence type, which is the text sequence type str or string, and we also looked at some of the operations that can be performed on the string. Now, Python actually provides 6 additional built-in sequence types, and they are the list, the range, the tuple, and these 3 types we'll be discussing in this section. And there's also 3 binary sequence types that will be the subject of future sections, but we'll talk about those. So there's actually a useful summary of the operations that can be performed on sequences. What I'm going to do is just open up some documentation and show you that. I'm going to paste in a link there, and you can see the link now. I'm just making it a little bit larger so you can read that on the screen. If you go to that page and have a look, you can see that there's a good summary, as I mentioned, of the various operations that can be performed. And the table itself is actually quite useful, but unfortunately, the actual text itself is written as a formal definition, and it's really not really that easy to understand. The good news is that we'll be explaining it all in this course here anyway. Now, looking at these operations on the screen, though, even though they're a little bit hard, a bit cryptic to read some of them what they actually mean, we've actually used the first 8 already in the course. And if you look at the next 2, min and max, they're probably fairly obvious as to what they do, give you the smallest item and the largest item. And even if the results they produce are not always what you might expect, which you'll actually find when actually using them. But count could have been useful in our previous challenge as well. This is the s.count, total number of occurrences. We could have actually used that to check that the input string contained exactly 3 full stops. So let's actually go back and check that out and see how to do that in some code. So what we could have done is started off and put IP address equals input. Please enter an IP address like so. And in terms of validating it, we could have done print IP address dot count and put the dot in there. So we're counting how many dots, full stops are actually in there. So if we actually ran that, please enter an IP address 192.168.0.1. You can see we've got the number 3 there. And again, we could just try another one. We could just try a bogus one, 10.5.4.3.2.1. And that's returning 5. Even though it's an invalid IP address, you can see that it's actually correctly returning the right number of full stops it's found. So that would have been very useful. There's also another one that we're going to look at in this section. If we go back to the form again, we're going to be using index of the first occurrence of x in S. So all these operations that I'm showing you can be performed on any sequence type, but we're actually going to be using them with lists here. Let's go back to the code again. It probably helps though if we start off by talking about what is a list. So what actually is a list in Python? Think of a list as a sequence of things. Now those things could be strings, numbers, classes, or pretty much anything else. So if a list can be a sequence of strings, and a string is itself a sequence type, which we talked about earlier, then it makes sense that a list can also be a sequence of lists, which it can. So this makes them incredibly useful, if a little bit confusing initially, as we're about to see. So we're going to actually start by looking at the dead parrot list we used when discussing for loops in a previous section. We're going to make a slight change and assign the list to a variable. So I'm just going to comment this code out. So let's type parrot list equals not Python, no more, a stiff, bereft of life. Again, Monty Python references there. And this time we've assigned it, as you can see, to a variable. And we can use our for loop, for state in parrot list, colon, and print this parrot is a state. So again, the list on line 3, it's created by enclosing the individual items in square brackets, as you can see there, and separating each item in the list with a comma. And we can actually run this to confirm it actually works. This parrot is, and you can see non-pointing was the first entry, no more was the second one, a stiff, and bereft of life. So it actually went through the for loop. Each entry is a separate entry in the list, and we were able to actually print a message out. And it's also quite easy to actually append to a list after you've created it. So if you wanted to do that elsewhere in the code, you could actually come down here and type parrot_list dot append and type in something like, or Norwegian blue. And then if we run that, we can see that we successfully added an entry to the end of the list by using the dot append. Now the other thing we can do is have a list of numbers. So obviously we've used strings there, but there's nothing stopping us from actually having numbers. So we could do something like even equals 2, 4, 6, 8. And we could say odd equals 1, 3, 5, 7, 9, like so. And we can put numbers equals even plus odd. print numbers. So here we are actually concatenating the even and odd lists, and we're assigning the result to a third list, a new list called numbers. So let's actually try running that first. And you notice we've actually got 2, 4, 6, 8, 1, 3, 5, 7, 9. So it successfully appended the numbers that were in the odd list to the at the end of the even list, and actually created a third list where we actually added it to the numbers. So the actual numbers list contains the sum of both of them. And we've got a couple of errors here, so I should actually make an attempt to actually fix those. So we need to be adding those white spaces. And again, it's a good habit to get into to do this for all our code to make sure the code is actually valid each time. And this is actually telling us that the list creation could be rewritten as the list literal. So again, that's some more advice from IntelliJ, but we'll actually leave that for the time being anyway. We'll come back to that. But looking at the list that's been combined there, as you can see, they're not actually in order. So obviously it'd be nice if we could automatically get those in order so they actually started from lowest number to highest number. And that's actually quite easy to do. So we can actually very simply use the sort method, which is part of a list, and type numbers.sort. Like so. And once we do that and run it again, you can see we've now got the numbers correctly in order. Now the sort method itself doesn't return the sorted list. And if you've actually used other languages, this may be what you expect. You may expect the sort method to actually return the sorted list. So in other words, this is not going to work. So if I'll give you an example, if we actually remove that and actually comment that line out, and if you did something like this, print numbers.sort, you might assume that that would actually print out the contents of what was the sorted numbers. And certainly that would be the case in other programming languages. But if we run that, we actually get none. We get something completely different. And the reason for that is that Guido van Rossum, the guy who invented Python, he chose this behavior deliberately. And the idea was to provide a hint that the sort method works on the object that is called upon rather than creating a new object. And that's very important here, that it's not actually creating anything. So the sort method or function, the idea of it is it actually works on the existing variable, the object. In other words, it doesn't actually create a new object. And that's why in this case, .sort return nothing. So we would then delete that code out again and come back here. So we've got at this point our list. Numbers.sort works on that list and resorts it, and then printing it out obviously prints out the same variable which has now been sorted and got the numbers in the right order like so. So if you're new to programming, some of this discussion may not make much sense. You might be wondering, what I'm talking about when I'm talking about the .sort returning an object. And you're probably quite happy with the way it works. And indeed, it actually does make sense and it's quite intuitive. But the reason I'm bringing it up is because it's particularly important that if you have seen this in other languages, you have to get used to this type of behavior in Python. Generally speaking, if a method acts on an object and changes it, mutates it in other words, and that's in Python speak, then the method's going to return none. So the method itself is going to return none, but the actual variable or object has been updated. Now there is a way around this. So if you want to create a new object rather than sorting the one you have, there's actually a built-in function sorted that's going to do that. So we can actually change this code out. So we'll get rid of the .sort, and what we'll do is come up here and delete that code. We can put numbers, but use a method called sorted, like so. And sorted is a function that's built into Python. If we run that, you can see we've got the same result here. We've actually got it sorted. And that does actually return the number, because obviously we're printing this out. So it's returned a new list containing the sorted numbers. So that's different to the .sort function you saw before. This sorted function actually returns the actual new object. And of course, with that said, we're printing it there, but there's nothing stopping us actually just putting numbers in order equals sorted numbers, like so, and then just print numbers in order, which essentially is the same thing. So that's going to work as well. If we run that, we get the numbers that are sorted in the right order. So at that point, obviously, we've got two lists. We've got numbers and numbers in order, and they've got the same items, but obviously in different orders. The first one, numbers, has got the numbers unsorted, and numbers in order obviously has got the sorted numbers. The other thing to keep in mind is at this point, even though they can both contain the same items, Python will not treat them as equal, as we can see with this code that I'm about to write. And it's an important distinction there. So if I type if numbers equals numbers in order, print the lists are equal. And again, they've got the same numbers in them, so you'd think maybe that would work. But we'll try putting an else in there. The lists are not equal. So if I actually run that, we actually get the message back, the lists are not equal. And that's because even though we've got the same numbers, they're actually in a different order. So obviously the first set of numbers was unordered and the second set of numbers was ordered. And as far as Python is concerned, they aren't equal. But we could do something like this. We could actually do a test for if numbers in order is equal to sorted numbers, print, and we'll actually copy the rest of the code there. So we'll just do exactly the same. Copy that, paste that. So now we're actually testing numbers in ordered, which has already been sorted, and we're comparing that to the return from the sorted function, which will actually be numbers, sorting the unsorted list to a sorted list. That should now come back and say they're equal. And the lists are equal at this point because obviously we've got numbers, same numbers, and also this both sorted as well. So again, if you're used to other programming languages, this may well be very confusing to you. The two objects are not the same and they would not test equal in Java, for example. But Python works as you would intuitively expect if you're new to programming, and it's obviously a bonus for you if you actually are new to programming. So I'm going to end this video here. In the next video, we're going to continue our work on lists, and we're going to look at some different formats, some ways to actually use replacement fields in lists and so on and so forth. So I'll see you in that next video.